Good afternoon, everybody. My name's Lainey.
I'm Allie.
I'm Isabella.
I'm Colin.
Oh, and I'm Mark.
And we've created a technology called BEETLE 5, or BB5. And we're looking to reduce the risk of radiation.
So BB5 is an autonomous robot swarm that's based off a dung beetle. And the purpose of the swarm is to collect radioactive topsoil using an integrated conveyor belt. And then once it goes into the machine, it has an internal bagging system that is used to contain the radiated soil. And the purpose of this is to try to save human lives from being reacting to the radioactivity of the soil. And then this usually happens after a nuclear leak or meltdown.
Okay, so with anything that we do, there's always going to be some small percentage or large percentage of human error. And when we're handling unstable materials like radioactive material, we really want to decrease that amount. So by using a robot, we can actually by using BB5, we can create a safer and more effective process that actually disposes of the radioactive soil, and by using a robot, we can then eliminate the need to risk human lives because the robots will be doing all of the collecting, and that's the only thing that's going to be exposed to the radiation.
When a natural disaster occurs and causes a nuclear meltdown, BeetleBots are there to clean up the radioactive topsoil in the contaminated areas.
So that was just like an animation of how our robot works.
Oh yeah. The BeetleBot collects and packages radioactive topsoil, then stores it on site. Mycelium and sunflower seeds are left behind to uptake residual radiation.
Oh, okay. The actual BeetleBot will have a few sensors on it. So a GPS and ultrasonic sensor, a Geiger counter, and an adjustable conveyor belt. But we have a demonstration here, and this only can move forward, and it has a flex sensor on it. And when the flex sensor hits this box, the robot will stop. So
You get a microphone?
yeah, bring him a mic, please.
So while Mark's setting that up, you can see on the bot itself, it has supposed to be basically simulating mandibles inside the dung beetle, and then these are just horns for aesthetically pleasing look. And then you can see right here it has a movable conveyor belt.
Okay. So the robot will just move forward, and then as it hits the box, the flex sensor will bend, and that'll cause the robot to stop. Of course, in the real robot, if it's ever developed, we're going to put an ultrasonic sensor in it, so that way it doesn't actually have to make contact with the obstacle, but it could get close to it. And as you can see, it stopped. Okay. So the flex sensor is usually supposed to bend the other way, and it'll stop more efficiently that way. And it did it in all of the test runs we ran, but I guess not now.
One more time. Come on.
Okay. So yeah, basically that's just our demonstration of the product. So now on to the next slide. Okay, so the BeetleBot will basically, it's not going to only have one unit, but multiple units to create a swarm, because obviously the BeetleBot the actual thing won't be much bigger than this. So we're going to create a swarm of BeetleBots, and they'll basically all follow these basic rules in order to clean up an area really effectively. So the rules are the robots move in a grid in order to make it as efficient as possible and to stop robots from overlapping each other. And then the positions of the robots are determined by the positions of other robots. So basically, one robot will have sensors on it to be able to detect the relative position of other robots. And then robots will assist each other in completing specific areas. So for example, if one robot has a more challenging plot to complete, then another robot, after it's done with its own plot, can come and help the robot that can't complete its own plot on time. And this is just to make the process more efficient and faster. And then so if a robot does break down, it'll send a signal out, and then that'll cause all the other any other robots in the area to come and finish the plot that robot was supposed to take. So when all plots are completed, the robots will move to the next assigned area, or if they're done cleaning up everything, they can go to a dumping location where all the radioactive and contaminated soil will be dumped.
And not only do we want to work on containment, but we also want to work on rehabilitation. So in recent studies, there's some certain species of mushrooms which have been growing naturally in the wreckage of Chernobyl. And we wanted to use this because they're tolerant to radiation, along with certain plants such as like pigweed and sunflowers, and try to spread that around where we do contain the topsoil or irradiated radiation, and hopefully leak out or pick up any of the extra leaked radiation that has spread into any of the water sources. And doing this, we could add on a certain piece of technology to the back of the robot, and that would distribute the plant seeds and mycelium, which would rehabilitate the contaminated area and quick start natural regrowth.
So, in conclusion, the autonomous swarm of robots will be used to collect and dispose of the radioactive topsoil. And then also, by doing this, we can make safer practices and reduce the amount of risk of human lives, because if we are able to stop any radiation, then we can reduce the amount of cancer or the amount of just possible side effects later on in life. So this could be utilized in such as Fukushima, which happened in 2011, so that this could be used to try to stop any contamination of the water sources or food, so that you can try to protect the people as soon as possible.
And while this is not a permanent solution or the whole solution, it is a great way to have a plan if a disaster like this does occur. And it provides a safety net and a feeling of more safety, stability. Yeah.
That's it.
Thank you.